taking the stuff like max min, mostly max min, and applying it to kind of more real world situations, not super real world. Like we're gonna find that most area you can enclose on a farm with a certain amount of density. Well, it's like kind of real world, right? But not like you're gonna go do it tomorrow or something.
It's like a math problem.
Crazy. Yeah. So we started applying like the derivative stuff we've learned recently to more real world things. So the first thing is like the physics application. So first of all, speed is absolute value of velocity. So speed doesn't have a direction. Like if I'm running away from you at 50 miles an hour, my speed is 50 miles an hour even though it's negative. And speeding up, slowing down. So if I have a positive velocity and a positive acceleration, I'm going forward faster, I'm speeding up. If I have a negative velocity and negative acceleration, I'm going backwards faster. So I'm speeding up, just speeding up in the negative direction. So if your velocity and acceleration are in the same direction, you are speeding up. And if they're opposites, you are slowing down. This would be like I have a positive velocity, I'm moving forward, but my acceleration is negative. So if I'm moving forward, but decelerating, that's like you're coming to a stop sign. Or the opposite would be like I'm going backwards, but actually positively accelerating. So I'm in reverse, backing out of my driveway, and then I stop, hit a car. Yeah, that'd be quite a deceleration. That'd be a jerk. So if they're in the same direction, like if they're both positive, you are speeding up. And if they're both negative, you are speeding up. If they're opposite from each other, you are slowing down. So you can write that down for notes. So this gives you just kind of a bunch of stuff to find. So find velocity, find acceleration. Let's put that in the word too. So S of t is usually position. Usually what they use. They could use h of t though. Also for height. They usually don't use p. And then the derivative of position is velocity. And the second derivative of position, or the first derivative of velocity, is acceleration. We've kind of talked about this as we've gone, but just making sure we have it in notes and do like official props out of this stuff. And then, like up and to the right are positive, down and to the left are negative. I think that's fairly intuitive. Yeah, so let's just do like number one and go through all these things. So for each problem, find the velocity function and the acceleration function. So like for number one, velocity is just the derivative, so negative 2t plus 20. And the acceleration is the derivative of that, so negative 2. So if you think about like negative t squared, that's a downward parabola, which is always concave down, right? If I have a parabola that's upside down, it's always concave down. So that's why the second derivative is always negative. So you, in this situation, it's like you threw something up in the air, it's always being pulled up but pulled down by gravity. That. Find the times when the particle changes directions. So what do I know is true when the particle changes directions? Velocity is 0. And we got to make sure it switches. But that's the first thing I'm going to do. So change direction. I'm going to set the velocity equal to 0. T will equal 10. I also got to find moving left and moving right, which fits right in with the change of direction. if I'm moving to the left, what's true about my velocity? Negative. Moving to the right, my velocity is positive. I'm going to set up my intervals like negative infinity to 10 to infinity, and I'm going to plug back in to which level? And the velocity, because I want to know if the velocity is positive or negative. You good? Did you get a packet from yesterday with these velocity things?
Yeah.
Okay, so if I plug in, let's say 0 to my velocity function, I'll get a positive number. So velocity is positive, which means it's moving right. And then if I plug in like 30, negative 2 times 30, negative 60 plus 20. So this is a negative number. So moving left. So I've identified the change of direction, where it's moving to the right, where it's moving to the left. And I've done the velocity and acceleration. Questions so far? What are you going to ask about it? Okay, that's okay.
That was your final. You never answered.
What do you mean?
Is that your final answer?
I'm not done yet.
Okay.
Wait, what email did you send me? When? I don't think I got it.
Oh. Maybe I said.
Okay, so times when the acceleration equals 0. So when the acceleration equals 0, I would set the acceleration equal to 0. And in this case, negative 2 can never equal 0, so in this case, that never happens. And then speeding down, slowing up, I think a number line is probably your best bet to get a look at this. I would put any critical points that I have from any level on the number line. In this case, it's just 10. And on top, I'm going to write whether the velocity was positive or negative. And on the bottom, I'm going to write whether the acceleration was positive or negative. What's true the whole time about the acceleration on this one? Negative the whole time, right? Because the acceleration was just negative 2. Like, it doesn't matter when I plug in for t, it's still negative 2. So acceleration negative, so acceleration negative. So we are speeding up if they are the same. Velocity and acceleration are the same sign. So are we speeding up from 10 to infinity? And we are slowing down if they are opposites. So negative infinity is 10. I'll do number 2 also. Just because this one didn't have much going on with the acceleration. I don't know. Some of you guys might be like, yeah, this is easy to get this. It's like something we're doing. Some people might need more help, more questions, whatever. What could I? Hannah, what are you looking for? Does that matter? Whose fault is it? Ethan's? Ethan, your head's too big.
You got big head. I got two people back there. You got big head.
Are you good? Okay. We should seat by height, like stadium style seating, so the tallest people have to go on the back.
Maybe you should.
Maybe you should put bleachers, but then you have to account for the people with bad eyes.
Yeah, so if you're tall and have bad eyes, yes.
Yeah,
Is that you? Do you have bad eyes?
We'd like bleachers.
No.
Bleachers would be sweet.
And then you put AstroTurf in here.
And then why do I need AstroTurf?
And then we have football tournaments.
Yeah, what's up? Ryan?
Oh, nothing. We just start like tackling.
You can interrupt this conversation. It's fairly stupid. Are you good? Didn't you have your hand up?
No, you said.
But that's a good seat choice then if you have bad eyes. Because it's in the back. That should help you see better. I can't tell you how many people I have that are like, yeah, my vision's terrible, and they sit like in the very back row.
It just doesn't make sense.
Doesn't make sense.
That's my set right here.
Jack says I got horrible eyes. So I just wear contacts.
Are we good on number 1?
That's you. It's off when you can't even see the road.
I can't see the road actually.
Alright, number 2. Do
What I drive on.
you have one of these packets that Mr. Crosby about this?
Yeah.
Thank you.
Good one.
Alright, find the velocity and acceleration functions. So those are just the first and second derivatives. So the velocity is 3t squared minus 46t plus 120. And then find the acceleration function. 6t minus 46. Where does it change direction? So what do I know when it changes direction? What do I know is true? Velocity equals 0. This looks slow. So I gotta set that equal to 0. So I can't factor a 3 out because 3 doesn't go into 46. So I'm gonna have to, well, I'm gonna try to factor kind of the guess and check FOIL method. I'm hoping I don't have to use, but quadratic formula. Could be,
What if nothing works?
I gotta use quadratic formula.
Negative b,
40 and 3 doesn't work.
negative b plus or minus square root of b squared
62 doesn't
times
work.
7 minus 40. Is it plus 40? Is it minus 40? And then over to it.
Oh.
I'll give you 10 points.
They got me do it. So this could be 10 and 12, right? Well, if I multiply 3 times 12, that's 36.
Oh,
And 1 times 10 is 10. 36 plus 10 is 46. So I need to put the 12 here. And the 10 there. So if I FOIL that, what do I get when I multiply these two together? Negative 36t. And what about this one? Negative 10t. If I add those up, I get that. And if I multiply negative 10 times negative 12, I get my positive 120. So that's just like playing with different combinations in your head until you can get there. If you're stuck, you can do the quadratic formula. Do we know the quadratic formula? Should we say it again?
It's
Negative b plus or minus square root of b squared minus 4ac all over 2a. What's a? 3. B is negative 46. C is 120.
yeah.
So if I set this equals 0, I get 10 thirds. You don't like what? 10 thirds? Did 10 thirds offend you in some way, man?
yeah.
Jack.
It doesn't divide evenly, so. Ethan actually, he's told me that.
So then all fractions are offensive?
Is that bad?
Yeah,
Sure,
that's
that's like 0.5, like 10 thirds.
Oh, I gotcha. Okay, so I gotta check my number line. So I'm gonna go negative infinity to 10 thirds. Please stop talking. 10 thirds to 12. 12 to infinity. You don't have to like work with the 10 thirds, so it doesn't really matter. I know that I need to pick a number smaller than 10 thirds, but that's easy. I can just choose like 0. So if I plug 0 back in, I'll think about plugging 0 into this because that's an easier form to plug 0 into. I get a positive number. So it moves to the right. 10 thirds is 3 and a third. So I need to pick a number between 3 and a third and 12. Let's say 10. So then I would probably plug in here, I think is easier. So if I plug 10 into this parenthesis, I get positive. If I plug 10 in here, I get negative. So the velocity is negative, which means moving left. And then 12 to infinity, if I plug in like 100, both of these parentheses will be positive. when it changes direction. I know when it moves right and left. Good there?
Yes.
And then the next question they're asking me is when is the acceleration equal to 0? So acceleration is 6t minus 46. I don't 60 equals 46. Is it okay if I write that? It's 60. It's 6t minus 46 equals 0. I think he's gonna get upset again. I'm afraid. So t is gonna equal 46 over 6, or if you want to reduce it to 23 over 3. Does that one also make you angry? So negative infinity to 23 thirds. 23 thirds to infinity. Again, you don't have to like work with those numbers. You just have to pick around them. I know. What's the most aesthetically pleasing fraction? Is 7/8? That's the first one I thought of. I don't know why. Is Devin aesthetically pleasing?
Whoa. 6 balls is pretty nice.
Oh, because it reduces?
And it's just
Okay.
thank you.
Alright, so 23 and 1/3 is like a little more than 7, right? 7 and 2/3. So just pick a number less than 7 and you're good. So let's say 0. If I plug 0 into 6t minus 46, I get negative. So this is a negative acceleration. And a number bigger than 7, so let's say I put in 10. 6 times 10 is 60 minus 46, so this is a positive acceleration. And then the last thing, speeding up and slowing down. So I'm putting any point I got from anywhere on the number line. So you gotta think a little bit to put them in order. 10 thirds, 12, and 23 thirds. So which is the smallest? 10 thirds. And then 23 thirds, because that's like a little more than 7, and then 12. Let's jump in.
Yes.
And then I'm just like kind of summarizing the work I've already done, right? So I know it moves to the right. Velocity is positive up until 10 thirds. Velocity is negative between 10 thirds and 12, which is going to cover both of these sections. And then to the right after. And the acceleration is negative up until 23 thirds. And then positive after. So if both sides are the same, are we speeding up or slowing down? Speeding up, and if the sides are different, we're slowing down. So we're speeding up in those two spots. I just ran out of room, so I'm doing some arrows and stuff. We're slowing down here. You guys can write smaller because you don't have to make sure people in the back with poor eyesight can see. Ben? No. You just did most like
actually.
I mean, you just had some questions like that on the quiz. They just were phrased as first derivative. Velocity. Yeah. Same thing. Questions on 2 here? It's not like graphing is some newfangled idea I've never thought of before. Are we gonna graph these? Wait a minute, what? But that doesn't come out even either.
I literally hate that fraction.
1/4 is that.
You have a problem when it's over 1 and you can't. It's like
Couldn't you simplify every number that's over 1?
they just look ugly.
Okay. I cannot disagree with your aesthetic, I guess.
Look at it and you
Take a look at number 6, please. Is there different instructions? I feel the need to A, point that out, and B, do a sample problem. So they're saying find the position, velocity, speed, and acceleration at the given value for t. So you're just finding each, position, velocity, and acceleration, and plugging in. T equals 4 in this case. And then speed is the only new thing. But if you get a negative value for speed, what do you do with it? Yeah, if let's say velocity is -8. What's the speed? Positive 8. That's what I was trying to say. You can't get a negative value. You guys do that in physics? Speed is the absolute value of. You what? Oh. Okay. Alright, so let's go through it. So, yes. Because it doesn't have a direction attached to it. So the velocity is 2t minus 20. The acceleration is 2. And then we're supposed to find the position at 4. 4 squared minus 20 times 4 plus 100. So 16 minus 80 is negative 64 plus 100 is 36. The velocity at 4 is 2 times 4 minus 20, so 8 minus 20, so negative 12. The acceleration at 4 is what? It's 2. There's nothing to plug in. And then, I don't know how to notate speed. You just have to write speed. Yeah. Speed. Yeah, so I'm just going to have to say, speed at 4. So what's the speed at 4 in this case? It's 12. The speed has to be a positive number. So velocity has a direction attached to it, speed does not. Velocity tells you which direction the person is going, speed just tells you how fast they're going. Questions on those examples I went through? Seem good? Alright, so finish the thing. Tomorrow we got we're not spending more than just a day on it. It'll definitely be our test or whatever, but I don't think we need to spend a ton of time on. That's not big. Yes, man. Jack. That's a very Ben question.